today, and this is going to deal with integrals. Improper integral simply means that you're going to have like some to infinity, a negative infinity to, or a negative to infinity as one of your bounds. So those are basically, let's say I have this over x inside of my integral. So if I was to look at the graph again, I see that that point exists. I went from -1, so they're at 0 to 0. This is bad, okay? So if that's bad, then that's going to be improper because I have that discontinuity. So those are going to be improper integrals, and we're going to learn what to do today when we go and take the integration of those. So you can look at the 3 different steps. So if I was looking at this first one that we talked about, so the integral from a to infinity, basically what we're going to do is just replace infinity with some letter. Now I don't care what letter, sorry, let me bring that up. I don't care what letter you use. You can choose B, you can choose K, whatever. But we're going to take the limit now as B approaches, so this just has to be the same, the infinity of the f of x. So same thing if I was going to do with that negative infinity to some bound. Then now I'm going to replace that negative infinity with a letter, and now the limit is going to approach negative infinity. Now the tough part is, let's say that I had both negative infinity and infinity. Then now you're going to break it up. So you're going to go negative infinity to some number plus that number to infinity. And then basically you're going to have to apply this rule here and this rule here. So it's just going to be a little more work, but not bad. So those are going to be those improper integrals with the infinities. So let's look at our first example. So our first example is the integral from 1 to infinity of 5 over x cubed dx. So I know that the improper part is this infinity, and then it's going to be bad at x equals 0, but that's not in our interval here from 1 to infinity, so I don't have to worry about it. So this is not in 1 to infinity, so we're okay here. So the only one I have to worry about is the one that has the infinity. So that's the only one that I'm going to replace. So we're going to give it, again, any variable name that you want. I'm going to choose k this time. So we're going to let k approach infinity from 1 to k. And I'm just going to rewrite this so I can do my nice little power rule here. So now I'm going to go ahead and take the inside and do this integral first. And then we'll go and do the limit second. So let's go ahead and do our integral, keeping the limit attached. So I did my antiderivative, now evaluated from 1 to k, and the limit is still continuing, so I'm still going to let this limit continue, and now I'm going to evaluate my k and my 1. Now that I have it this turns into a chapter 1 problem, and I can go ahead and take the limit because I'm done with the antiderivative. So I plug in my limit as k goes to infinitive. I'm bigger on bottom, so this is 0. Plus, that's just a constant, 5 over 2. So my answer is 5 over 2. Pretty dang cool. So basically you were finding this part. If you were to look at this graphically, we are going from 1 all the way to infinity. See, if I plug in 1, I am at 5 when I plug it into this f of x here. And it's just going to go down all the way forever and ever and ever. So you are finding this area that went on forever, but you found it to be finite. How cool is that? Very cool. Okay, so you guys try the next one and then check with me. See if you can't set it up and try the next one. And you're going to do a nice pretty little U-sub. So you can pause this and then unpause when you're ready to check. Alright, so with my U-sub now, when I go to change my bounds, I just want to make sure that you remember if you plug in 1, the ln of 1 is 0, and the ln to infinity is still going to infinity. So we're still taking now 0, but we're still going to infinity. And now I have u du. So let's go ahead and replace that infinity with a variable. How about b in this case? And now we're going to go let b go to infinity. So I'm going to do the inside of the integral and do all of that, and then I'll do the limit. Okay, so now as I look at this, I can see as I go to infinity, this is bigger on top, so that's infinity minus 0, which is infinity. So if I was to look at the graph of this guy, this ln of x over x, and I'm going from 1 to infinity, so I would keep going, this area actually grows infinitely here. And as we go along and as we get into chapter 8, we're going to call this divergent. So this guy actually diverges. It's kind of a nice little term to get used to. And the one up here that gave us a number, we're going to say that that converges. So just some terminology as we keep going. Okay, so those are the easy ones. I know you love it when I say that. Now let's get into some fun ones. Oh yeah. So now to think through, this is not just a simple little integration, but I do see this guy and this guy looking like two parts. And if I did this guy as my u, it goes down, so it looks like a one-step integration by parts. So that's not too bad. So I'm going to let my u, in this case, be my 1 minus x. So the du is just negative dx. So that's really nice. So now my dv is going to be e to the negative x dx, and my v is negative e to the x. So this will become the integral from 1 to infinity. Oops, just kidding. I can do integration by parts. Okay, one stepper. Okay, so this will now be, let's see, let's replace this with a variable, and then we'll move forward so we can get our limit. Come on, doodles. The limit, I'm going to call it a, and now a goes to infinity. Again, you can pick any variable. Okay, so the limit as a goes to infinity. And we're going to do u, v, and this needs to be evaluated from 1 to a, minus the integral of v du, so negative and a negative become the positive, and again that's 1 to a. Okay, I can now plug this in, my f of b minus f of a part, or f of a minus f of 1 in this case. And now this is an easy integration, and I can evaluate it as well from 1 to a, then we'll take the limit. So let's go ahead and try that. And again, pause, try it, and then check. Okay, so this is what I got. Here I can see that on this first one, this grows bigger, so that's going to be 0. On this one, this grows bigger again, so that is 0. And then I have minus 1 over e, which is going to give me a negative 1 over e for my overall answer. Oh gosh, push it up. Okay, so let's try that again. This is bigger, so it becomes 0. This one's bigger, so it becomes 0. And then that's your 1 over e. So again, the vocab we're going to kind of connect with that is that this is going to converge at 1. So it converges. Okay, let's do the next example. Ha ha ha, now we have a double up here. So now we have a negative infinity and a positive infinity. So we're going to have to split it up, so pick any number that you want to go into the middle. The easiest number that you can think of, I'm going to pick 0. I don't care what number you pick, as long as you do it correctly. And you pick the same number, right? It has to go, stop and go at the same number. And as we now think of this, we're going to think of it as 2 separate problems completely. So let's go work on this one now. So I'm going to replace that negative infinity with some variable. I'm going to do a. So a is going to approach negative infinity. And I'm going to go ahead and set this up a little bit because I can see when I have a plus and I see the squared here, I'm thinking arctan. So I'm going to go ahead and set that up. And let's think of this. Let's see, I'm going to use b. I don't want to use the same one. So b is going to approach infinity here. So now I have this. And see if you guys can keep going. I'm just going to remind you, when you do get to arctan, what that graph looks like. I know I don't have to remind you, you guys are all so smart and you remember. Okay, so the limit as you go to infinity of arctan, we've discussed this, is going to be pi over 2. And the limit as we go to negative infinity of arctan is negative pi over 2. So you're going to have to use that as you try 2 problems. So pause me, try it, and then unpause. And then let's go back and check once you unpause.